Hello everyone, welcome back to Caesar Education. In this video we are going to go through the question paper from grade 12 for mathematics paper 1. This was written in November 2022 and it was for 150 marks. Hopefully I won't take 3 hours of your time explaining how I'm going through the problems. This is the NSC question paper. They have a lot of instructions here, but I'm only going to pay attention to clearly show all calculations, diagrams, graphs that you have used in determining your answers. And also, I know that the diagrams are not necessarily drawn to scale. That will be useful. The way I'm going to structure the videos is that in this video, I will answer only question 1. And then I will post another video with question 2, another video with question 3, and so forth. So that you pay attention to the concepts of question 1, and then when you go to question 2 you'll be ready for it and you would have understood, and this video is not so long. So in NSC, question 1 is always algebra. So by algebra we are talking about they either will make you solve for x, or you will simplify or solve simultaneous equations or exponent. Just stuff like that. It's actually, I know every teacher will tell you that these are the easy marks. So make sure that you got your algebra on lock. 25 marks just for these questions out of 150. Then you know that you are on the right direction. So now I'm going to introduce the screen where I'm going to write on. Now, with question 1, we're going to number them exactly how they are numbered in the question paper. We're going to go with 1.1 where it says solve for x. Now 1.1.1 is 3x minus 6x plus 2 equal to 0. Now, this is an equation for the mere fact that it has an equal sign. And the way that an equation works, it says that whatever is on the left-hand side must be equal to whatever is on the right-hand side. And whatever we do on the left, we must also do on the right-hand side. Now, when you take these two brackets, bracket 1 and bracket 2, if this entire expression is going to be equal to 0, that means one of these brackets must be equal to 0. Remember, when you take anything, 2 times 0, 3 times 0, anything multiplied by 0 will be equal to 0, which means that one of these brackets is equal to 0. So what we're going to do is that we're going to take the first bracket and say, okay, maybe this bracket of 3x minus 6, the brackets are not necessary, is equal to 0. So that if this is equal to 0, then x plus 2 multiplied by 0 will be equal to 0. Or this second bracket of x plus 2 will be equal to 0. So one of them will be equal to 0, but we don't know which one once we substitute our x. So let's suppose that maybe it's this bracket that is equal to 0, 3x minus 6 equal to 0, or the x plus 2 is equal to 0. Now we solve for x just like they requested in our question. So you know that whatever you do on the left hand side, you must do on the right hand side. So on this side, we're going to add 6, and then we must add 6 on this side also. So we call this transposing. We are taking this 6 and then taking it to this side. Another way that you can look at it is by saying my 3x minus 6, I add 6 and it is equal to 0. So that this 6 disappears, so that we are left with 3x. But whatever you do on the left hand side, you must also do on the right hand side. So we must also add 6 on that side and that will give you, this will subtract each other, and you'll be left with 3x equal to 0 plus 6 is 6. It's the same thing here when you transpose. You just take in the number, moving it to the other side, and then it changes the sign. So it's now positive. So now to detach this 3 from the x, we're going to divide. Now remember, what you do on the left, you do on the right. If a coefficient is attached to a variable, to detach them, you are going to divide. And if perhaps it was x over 3 and you wanted to remove this 3, then we would have multiplied. So to negate a division, you multiply. To negate a multiplication, we divide. And whatever you do on the left hand side, you must do on the right hand side. Now x is equal to 2, but that's not it. We also have x plus 2 equal to 0, and just like we explained, we transpose the 2 to the other side, it changes its sign, becomes negative, and then it is equal to 2. So when we solve for x for 1.1.1, x will either be equal to 2 or equal to minus 2. If we put minus 2 here, it will give us 0, and then whatever we get here multiplied by 0 will give us 0. The same thing on this side. If we put 2 here, substitute 2 into x, it will give us 6 minus 6 will be 0, and then whatever we get on this side multiplied by 0 will give us 0. And that's how equations work. The left hand side must be equal to the right hand side. I hope you understood that one. I'm gonna now do 1.1. An interesting thing is that on the question paper they say correct to 2 decimal places, and once they say correct to 2 decimal places in solve for x, we know that they are hinting that we should use the quadratic formula. Now the quadratic formula, you will find it in your list of equations at the back. If it is not there, it will be very important for you to know it by heart. It is quite a simple formula that goes that x is equal to minus b plus or minus root of b squared minus 2ac all over 2a. Now what is b, what is a, what is c? We can see that the highest order here is 2, right? X to the exponent 2. The highest exponent is 2. If the highest exponent is 2, we are dealing with a quadratic equation. And the format of a quadratic equation is given by ax squared plus bx plus c equal to 0. So which means that this a is given in this equation by 2, the b is minus 6. Let me write them down so that we don't forget them. We have ax squared. That means our a is equal to 2 plus bx. Our b in this case is minus 6, and then we have plus 1 plus c, which means our c is equal to 1. Let's substitute them into the quadratic formula. We say x is equal to minus b, and we found out that our b is minus 6, plus or minus the root of b squared. Our b is minus 6 squared minus 4. This is 4, not 2. Sorry for making that mistake. This is 4 and not 2. So minus 4 into a. Our a is 2. Our c is 1. And they are all under the square root, and it is all divided to 2a. and we find out that our A is 2. 8 now over 4. As you can see that the question paper says correct to 2 decimal places. So we just enter our 6 plus, we cannot enter plus or minus. So we're just going to start with a positive, the root of 28 over 4. You see it gives us a fraction there. We're just going to press this SD here. This SD in your calculator will give you the decimal places. So our X is equal to 2.82. They said correct to 2 decimal places. So we are not going to write that entire number. We are just going to write 2 decimal places. But it is not only positive. You see in our calculator here, we put positive. So we must also solve it for when it is negative. So we're gonna now switch it and say subtract, because here it says plus or minus, and this 2.82 is for when it is positive. So we're gonna say or X is equal to, we put a negative there, it gives us a fraction again, and then now we get 0.18. You have x squared minus 90 is greater than x. This is no longer an equation. Because of this inequality sign, we call this an inequality. So this side is greater than this side. Now, the way we're going to solve it though, we're going to approach it as if it was an equation. The first thing we're going to do is take everything to one side. Preferably, we want our x squared to remain positive, right? So the first thing that we're going to do is keep x squared that side, transpose x, which becomes a negative x, minus 90 greater than, we are left with nothing once we move the x to the other side. So we are left with a 0. What we did is just take the x and move it to this side, and it changes sign the same way it does with equations. After we do this, the next step is to factorize. 1.1, all of the questions are saying solve for x. So we are going to factorize this quadratic inequality so that we can find the values of x. Remember that if you are not sure how to factorize, especially when you see such a big number as 90, remember to use the quadratic formula. The quadratic formula will give you values of x, and then but remember that this is an equality, so the values you get, x will not necessarily be equal to those. Now remember, if we have x squared here, we'll have x on both sides. Now the interesting thing about factorizing is that you know that when you have a negative c, when your last term is negative, then you know that the terms in your bracket will not be the same. It doesn't matter which bracket it is, but the factors of 90 that I'm going to put here, it will matter which bracket that they are going into. Now the first step is to say what factors of 90, when you multiply them together they give you 90, but when you add or subtract them they must give you 1. They must give you the coefficient of the middle term, which is b there, and in this instant we have 1. We have 9 and 10. Now 9 times 10 is 90, but 10 minus 9 is 1. So we are looking for 1. So these factors are good. But now, which bracket does 9 go into? Which bracket does 10 go into? Now, the larger factor the larger number between these two will take the sign of the middle term. Now, since the middle term is negative, 10 will go into that bracket with a negative, and then 9 will go into the other bracket. And that's how you factorize. But now, we just don't want to factorize. We want to solve for x. The next thing that we're going to do now is we're going to draw a quadratic function. You know that a here is positive, so our quadratic function will be concave up. You just draw it like this. That will be sufficient. So after you draw this, you must find what we call critical values. Now, critical values, imagine them this way so that you can pass. The solutions to this, if there was an equal sign, so we're gonna have x minus 10 equal to 0, or x plus 9 equal to 0. This is this bracket, this is this bracket. Now, x in this case is equal to 10, or x is equal to negative 9. Now we're gonna put those on our quadratic function there, negative 9 and 10. Now, this is not necessary to put when in your answer sheet, so just put this and tell them that, oh, these are the critical values, x equal to 10, x minus 9. Now, because it says it is greater than 0, we have an inequality here. Our inequality says it is greater than 0. This line here, this horizontal line, that's our 0. Imagine that as your 0, so this is where y is equal to 0. And if it says that it is greater, we are looking for is above 0, because this inequality says that it says it is greater than 0, so it is above 0. Now our function is above 0 from this point here. This is above 0. Let's say our function continued. Now these values are above 0, these values are above 0, and they will go on. This function will go on until infinity. So what we're gonna say, just put arrows there. It's fine if you just put arrows, because if you do this and then you don't do it until infinity, it will seem as if you are saying, okay, it ends here where you stopped. So just draw arrows there. So that means that our x values exist where our function is less than negative 9. You see, from negative 9 go in that direction, our function is above 0. So this is where our values are less than negative 9, meaning that direction. So x is less than negative 9. Notice that our inequality here doesn't say less or equal to, so we won't include an equal sign here. Or we come to this side. Our function again exists from 10 going upwards. Our function is above our 0 from 10 going upwards, which means our x values are greater than 10. So we're gonna say, oh, x is greater than 10. Again, it is not greater or equal to, it's just greater than 10. And that is our final solution. Another way you can write it is to say, okay, our x value goes to negative infinity until 9, or our x values go from 10 to infinity, because it goes from 10 all the way until infinity. It comes from negative infinity until negative 9. X minus 7 root of x equal to 12. The thing that we want to do here is that to make it simpler for us, we are going to change this so that it is more convenient to work with. So the first thing I would say is that let the root of x be equal to k. It doesn't have to be k. It can be any variable that you want. So now that we have we know that the root of x is equal to k, we are going to rewrite this equation and substitute root of x with k. Now x, it is if you put root of x multiplied by root of x, you get x. So which means that this, if you have x is root of x squared. So if root of x is k, that means now for our x we will have k squared minus 7. Our root of x is now k equal to 12. Remember that we always want to transpose and have one side as equal to 0. So we are going to move the 12. Then once we move the 12, we will have k squared minus 7k minus 12. The positive 12 will come this side and become a negative 12. Now here we are again, and we are going to factorize. So you can see by now that factorizing is important. So make sure that you remember how to factorize because you're gonna need it a lot. Remember that question one, we say that they're the easy marks. So always be ready to factorize. We're gonna start with the k and say, okay, we're gonna have k and k on both brackets. Now let's go back to what we learned here. We said that if the last term is negative, that means the signs in the brackets will be different. If the last term, our c, is negative, that means we'll have different signs in the bracket. So, and once we do that, we put one negative, one positive. It doesn't matter which bracket we put which, as long as they are different. Now we are going to look for factors of 12, that if we multiply them they will give us 12, but if we subtract or add them they will give us 7. Can you think of any? I'm thinking about 4 times 3. Now 4 times 3 will give you 12, and 4 plus 3 will give us 7. I just noticed the biggest mistake. I hope you noticed it, so that I'm the dumb one and we are not both. Not both of us don't know what we are doing. So this was giving us minus 12. So this is minus 12. When we transpose the minus 12 to this side, it will become positive 12. You can see on the question paper there, it is minus 12 and not positive 12. So when we transpose it, it becomes positive. And once our last term is positive, that means the signs in our bracket will be the same, and it will be the sign on the middle term. So which means we'll have both negative. Signs in the brackets will be the same because the last term is positive, and which sign it is, it will be negative because the middle term is negative. If the middle term was positive, both signs would be positive, which means that actually we are going to use 4 and 3 because it is positive. So we are going to add our signs are the same, so we are going to add our factors. So we will have 4 and 3. The signs are the same, so it does.
The following seconds of this video is a photo of the rest of the problem. For some weird reason, I forgot to press record while I was solving the rest of the problem. Just know that I found the factors 4 and 3, I put them in the brackets and solved for k. But k was equal to the root of x, so I substituted the root of x back into my problem and then solved for x, which I found to be 16 or 9.
We are given two equations for 1.2, 2x minus y equal to 2 and xy equal to 4. Now what I did is that from both equations I look for a variable that is standing alone without a coefficient and without an exponent. In this case I see that it is y, so I make that y the subject of the formula here, and then I name that equation as equation 1, and the other equation I leave it as it is and I name it equation 2. Now after I do that, I'm going to take this y, whatever it is equal to, I'm going to substitute it in equation 2. So I sub equation 1 into 2. So where I see y in equation 2, I'm going to put this instead of a y, because this is equal to y. So I'm just gonna I'm now gonna have x equal to 2 multiplied by 2x minus 2, which comes from here and takes the place of y, and that is equal to 4. And now I just simplify and remove the 2 so that I have a way simpler equation here to factorize, right? So now when I factorize, I will have x on both sides. This should be simple for us now, that when you have a negative sign on the last term, that means the signs in the brackets will be different. And then we find the factors of 2 that when we add or subtract, they give us minus 1. So 2 times 1 will give us 2, and 2 minus 1 will give us 1. So now the bigger factor takes the sign of the middle term, so 2 will come in here and 1 will go in there. So now we know that our values of x will be x equal to 2, or from here x will be equal to negative 1. But 1.2 says solve for x and y. Now that we have x, we can take those values of x and substitute them to equation 1 so that we can find the values of y. So we have y equal to 2x minus 2. So in the place of x, I am now going to substitute with 2. So I have 2 times 2 minus 2, which is 4 minus 2 is 2. Or on this side, I'm going to have 2 into, put the value of x, which is minus 1, minus 2. So my y will be equal to minus 2, which is minus 4. So on this side, your values of x and y, your x will be 2. Let me use a different color. Your x will be 2 and your y will be 2. And on this side, if your x is negative 1, then your y will be minus 4. Okay, let's go to 1.3 now. Now 1.3 says, show that 2 times 5 to the power n minus 5 to the power n plus 1 plus 5 to the power n plus 2 is even for all positive integer values of n. So for all positive integer value of n, this expression must be even. Now, what are even numbers? Even numbers are numbers that can be divided by 2, and when you do that, they will give you an integer. They will not give you some decimal. Examples of those will be 2. It can be divided by 2 to give you 1. 4 divided by 2 will give you 1. So even numbers are all 2, 4, 6, 8, 10. Numbers that can be divided by 2 to give you 2. Now, if I want to show that this expression is even for all integer values of n, I must prove that this expression can be divided by 2, right? So let's start by simplifying. Our expression. Can I sound more interesting? So to simplify this expression, we are going to do what my teacher used to call throttlers. So we have 2 times 5 to the power n minus 5. This 5 to the power n plus 1. We can break this n plus 1 into different bases. So when you do that, remember that when you have plus 1, that means your bases were multiplied and they were the same. The rule of exponent is that if the bases are the same, you add the exponents, right? So which means here, before it became 5 to the power n plus 1, we had 5 to the power n multiplied by 5 to the power 1. If the bases are the same, you add the exponent. So now we're just breaking it down instead of going that direction with throttlers. Now that is plus 5. We do the same thing, 5n into 5 squared. Now you notice that all these terms, we can take out a common fact. They all have 5 to the power n. Term 1 has 5 to the power n, 5 to the power n, 5 to the power n. Now we take out the 5 to the power n as a common factor. What are we left with inside? Here, if you take 5n, we'll be left with 2. Minus, if we take 5n here, we'll be left with 5. Plus, if we take 5n here, we'll be left with 25. Now, if you simplify what's inside there, you'll see that you will have 22. And we have 5n on the inside. Now, when a number is multiplied by an even number, it will be an even number. When a number is multiplied by an even number, it will become an even number. Because 22 is an even number. If you take 22 and you say 22 divided by 2, it will give you 11. It gives you an integer, which means 22 is an even number. So whatever this is, if you multiply it by 22, the answer will be an even number. That means that if we take 2, which is even, and multiply it by 3, which is an odd number, the answer gives you 6. And that 6, it is an even number. So any number multiplied by an even number will give you an even number. So if this is an even number, whatever positive integer of n is, as long as it is multiplied by this even number, it shows that our expression will be even for all positive integer values of n. Why? Because it is multiplied by an even number. That's 3 to the power y plus 1 over 32 equal to the root of 96 to the power x. Now we want to solve for x and y in this equation. Now as soon as I see exponents added here, I know that, oh, this is paying homage to throttlers. So which means that we have to throttler this. We have to break it down. Now if the bases are the same, you add the exponent, which means this used to be 2 bases, and then they were multiplied together, and then their exponent were added. And if their exponents were added, that means they were the same base. So here I will have 3 to the power y multiplied by 3 to the power 1. Now 32. This 32, I want to also find its bases. I want to also write it in exponential form. And the good thing about a calculator is though I can just press 32 and say equal to, and then press shift this button that says factors, shift factors, and then it will give me 32 in an exponential form, and you can see that it is 2 to the power 5. Now let's focus. 32, I am now going to write it as 2 to the power 5, and that is equal to 96. I am going to do the same thing again with 96 and say 96 equal sign shift factors. Now it shows me that for 96 the factors will be 2 to the power 5 multiplied by 3. So we write it in that form and say, okay, 96 is 2 to the power 5 times 3, all to the power x, all under a square root. Now the interesting thing about this one is that remember that a square root can also be written as to the power of half. So instead of writing this big expression, I am going to substitute and say, okay, that is equal to 2 to the power 5 times 3 all to the power x over 2. Our square root now becomes 1 over 2 multiplied by the x that was already there. We have x to the power 2. Now we simplify this, the exponent multiplied the inside exponent. We have 2 to the power 5x over 2 multiplied by 3 to the power x over 2, and all of this is equal to 3y multiplied by 3 over 2 to the power 5. Now we are in the final stages. Now I'm going to use a black pen. We are finding an answer now. So what we are going to do now is put all of this we are going to put all of this so that they are all bases multiplied to each other. So we'll have 3y1 plus 1 multiplied by 2. Remember, a denominator, if it goes upwards to join the upper class, the exponent becomes negative. So it will be 3 to the power y plus 1 multiplied by 2 to the power negative 5 equal to 5x over 2 multiplied by 3x over 2. The reason why I joined these again is because I noticed that each side has the base 3 and 2. So I want them to be similar to each other. Now remember that we are dealing with an equation here, and with an equation this side must be equal to this side. The left hand side must always be equal to the left hand side. So if you have the same bases 3 and 2, that means whatever the 3 exponent is, that must also be the exponent of the 3 this side, right? Which means that y plus 1 must also be equal to x over 2, because they are both 3, and if they are not the same, then this side will not be equal to this side. But to make it easier for me, I'm going to take the exponents of 2 first, because I can be able to solve for x, because they have one variable, where this has y plus 1, it has y, and this one has x. So I'm going to say 5x over 2 is equal to minus 5. The exponents of the base 2 must be equal, or else the left hand side will not be equal to the right hand side, and always the left hand side must be equal to the right hand side. So when I solve for x here, I multiply by 2 on both sides. I have 5x equal to negative 10. Divide by 5 on both sides, I will have minus 2. I now know the value of x. What is the value of y? Y plus 1 equal to x over 2. The exponents of the base 3 are equal. Now I can equate them because I now know the value of x. So I have y plus 1 equal to negative 2 over 2, because I now know the value of x is negative 2. And then my y will be equal to, this will be equal to negative 1. Transpose this 1, it will become negative 1. So y is also equal to negative 2. And now I have the value of x and the value of y. Please, for us to continue making videos and making better videos, please like and please subscribe. These videos will get better. We'll start to use some technology and I will sound more enthusiastic. See you on the next video when we do question 2.